Okay, let's start. Hi everyone here and welcome to my talk, Hacker's Perspective on AEM Application Security. A year ago in 2019, I challenged myself to find a critical server-side security vulnerability in AEM. And this talk is about a journey I did to achieve this. I'll describe in details what I found. We will start from a small introduction part. So who am I? My name is Mikhail Egorov. I'm an independent security researcher and bug hunter. I live in Moscow, Russia. Before I became full-time bug hunter, I worked as an application security engineer and security researcher for roughly 10 years. But thanks to companies that launch bug bounty programs, now I work for myself. I mostly report security bugs on Bugcrowd and HackerOne platforms. I provided links to my public profiles on both platforms in case you have an interest. I enjoy attending security conferences. From time to time, I present my research work as a speaker. I provided links where you can find all my previous slides from different conferences. On the previous adaptTo, I already have had a talk regarding a view on AEM security from a hacker perspective. I talked mainly about AEM misconfigurations that lead to security problems and disclosed few server-side request forgery vulnerabilities. I definitely recommend to check this out in case you are interested in AEM security and missed the talk. In this session, we will talk about serious vulnerabilities I've uncovered in core AEM components in 2019. All vulnerabilities were responsibly disclosed to Adobe, and the slides for this talk were also reviewed by Adobe in advance. Adobe patched those issues and acknowledged me for the findings. Also, I'm the author of the toolset for AEM hacking. It's an open source tool and represents a set of scripts for assessing security of an AEM web application as a black box. It utilizes some tricks to bypass AEM dispatcher and exploits various security misconfigurations and vulnerabilities. You should check out this tool if you haven't heard about it yet. I promise you can find unique security issues using it. Okay, let's move to the vulnerabilities. Adobe Security Advisory APSB 1948 includes 3 issues I've reported. For 2 of them, Adobe assigned severity important, and for code injection vulnerability, Adobe assigned severity critical. According to Adobe's rating system, critical severity means that a vulnerability, if exploited, would allow malicious code to execute and potentially without a user being aware. Important vulnerability, if exploited, would compromise data security, potentially allowing access to confidential data, or could compromise processing resources. 2 vulnerabilities I've reported belong to XML external entity injection issues, or XEE for short. Such issues occur when XML parser is used to insecurely parse user-controlled XML data. The severity of XEE issue mainly depends on 2 things. What an attacker could see, could he see XML document after parsing, and what's allowed by an XML parser. Are general entities allowed, are parameter entities allowed, or it's possible to load external schema. Depending on the answers, an attacker can read local files potentially containing sensitive information, or make network requests on behalf of the vulnerable component. Let's see some examples. In the first example, if an attacker sees parsed XML document and general external entities are allowed, In that case, he can read local files from a server. Here, an attacker defined entity called XXE that references XEE password file. After parsing of such XML document, we see that the contents of XEE password file is included inside resulting XML. In the next example, attacker doesn't see the resulting XML and general external entities are prohibited, but external parameter entities are allowed. An attacker can send HTTP GET request somewhere, including localhost, on behalf of a vulnerable component. In case general and parameter entities are prohibited, but external DTD loading isn't blocked, an attacker can similarly to the previous example send HTTP GET request somewhere. Let's proceed with the first XXE issue in guide internal submit servlet. It has a CV number CV 2019-8086. On the slide, you can see the definition of the servlet. To invoke it, we should have a GCR node with FD-AF components guide container resource type, and further send post request using selector af.internal-submit in the URL. Let's see how the servlet actually works. First, we create a fresh node with desired resource type FD-AF components guide container. To invoke the servlet, we send the following HTTP post request. In the request, we specify guide state parameter in the body of post request. JSON data should be passed in this parameter. And JSON attribute with name guide prefill XML contains XML document as the value that is parsed by the servlet. What's good for us as an attackers if we use AF data element as the root of our XML. Value of this XML element is reflected back in the processed XML document. In this example on the slide, we see that value test is reflected back in the response. We can use this XML document with XXE attack payload to read local files. We have external entity with name A for the XEE password file, and we are referencing this entity inside value of AF data XML element. When we use our XML document with the attack payload inside guide prefill XML JSON parameter, we observe that contents of XEE password file is present in the response. There are some difficulties we should overcome to successfully exploit this vulnerability. Firstly, we should have a GCR node of type FD-AF components guide container, and we will return to this problem later. Additionally, we have to know full file names of local files on the server. And lastly, usually AEM web applications are placed behind web application firewall, like Cloudflare. For file names, luckily in Java, we can specify directory names instead of a particular file name in XXE attack. XML parser will happily print directory content to us. And to bypass annoying web application firewall, we can JSON encode XXE payload. It turns out that guide internal submit servlet is using different data formats that are nested one inside another. XML is packed inside JSON data structure, and JSON further is URL encoded. If we JSON encode each symbol in XXE payload as a Unicode code point with \u, So web application firewall will be confused because web application firewalls usually are not so smart when it comes to multiple nested levels of data decoding. Here you can see a Python script that does JSON encoding of XXE payloads. Here you can see if we place obfuscated XXE payload with JSON encoding, the attack still works. For directory listing, we use XXE payload that contains directory path instead of a file name. We reference XEE directory in this example. And it works. We see the listing of XEE directory. This allows an attacker to get any local file on a server without any hassle. What's about existing of GCR node with proper resource type? Luckily, demo content that's included in VRetail or geometrics packages contain nodes of desired type. If an attacker has access to Query Builder servlet, he can find desired nodes using property and property value predicates as shown on the slide. Further, GCR node content user-generated XEE commerce smart lists is usually writable by anonymous user. And we can easily create node of desired resource type if post requests are not blocked. It was a surprise for me that on some versions of AEM it's not possible to read local files. General external entities are prohibited. However, parameter external entities and external deloading are allowed. So it's possible to send HTTP GET request blindly, performing server-side request forgery attacks. Next, XEE injection vulnerability has been found in WSDL Invoker servlet. It has a CVE number CVE 2019-8087. On the slide, you can see the definition of the servlet. To invoke it, you should have GCR node with resource type FDF component guide container and send post request using selector af.wsdl in the URL. On the first step, we create a GCR node of desired resource type. The servlet accepts post parameter named WSDL endpoint. If we specify URL to a server controlled by us, we will receive GET request from AEM instance, as shown on the slide. It turns out that servlet tries to download a WSDL file and parse it. To demonstrate how the servlet works, we can use sample WSDL file from URL presented on the slide. If we place an URL to a real WSDL file in WSDL endpoint parameter, we will get JSON output that reflects some data from the original WSDL file. So we have XML parsing of user-controlled data, and we are able to see a partially XML document after parsing. However, simple XXE exploitation method by referencing a local file on the server using external general entities is not working here. We should use more clever approach. On the slide, you can see modifications that are introduced to the original WSDL file. Inside doc type definition, we reference an external DTD schema from our server using external parameter entity. This DTD schema defines external general entity named internal that we use inside SOAP action attribute. DTD file looks like this. I will not deep dive into details how XXE injection attack works here, but we can see that this DTD file references a local file as the password we want to retrieve. You should place both WSDL file and DTD file on your server. When you specify in a WSDL endpoint parameter allocation to the malicious WSDL file and invoke the servlet, you will get the contents of its password file in the response. To exploit this, again, we need a GCR node with a proper resource type. Demo content that's included in VRetail and geometrics packages contain such nodes. And another option that GCR node content user-generated at the commerce smart list is usually writable by anonymous user. I observed that on some AEM versions, WSDL invoker servlet is not present, and we are not able to exploit the vulnerability. Let's move to code injection vulnerability in guide submit servlet with a critical impact. It has a CVE number CVE 2019 88. On the slide, you can see the definition of the servlet. To invoke it, you should have GCR node with resource type FDF components guide container and send post request using selector af.submit in the URL. We should create a GCR node of the desired resource type, but note that for guide submit servlet, GCR node additionally to resource type should have enable a server validation attribute that have values set to true. In post parameter guide container path, we specify a path to a GCR node we created on the previous step. When we invoke the servlet, we observe 500 HTTP response with an error from Rhino, JavaScript engine, saying native object cannot be cast to Java util map. It turns out that somehow guide submit servlet passes user-controlled data from HTTP request to Rhino engine. One particular piece of user-controlled data that is used to construct and evaluate JavaScript is host header. We use quote character to close JavaScript string. Further, we create new instance of Java process builder to launch a calculator process. However, in some cases, especially when AEM is placed behind web application firewall or CDN, we are not able to specify arbitrary values inside host header. Otherwise, we will get 400 HTTP response. But we have a workaround for this case. We can use X-forwarded host header similarly to host header to spawn a calculator process. X-forwarded proc header works in similar way as well. For some AEM versions, guide submit servlet behaves in a different way. And Rhino engine is sandbox, limiting permissions of JavaScript we are executing. We can spawn operating system processes or access files within a sandbox. The only thing we can exploit in that case is server-side request forgery attack by performing network interactions. They are allowed within a sandbox. And good news that we can fully exfiltrate the response. Using this JavaScript injected code, we can make a GET request to an arbitrary network resource. We make POST request, and in the URL parameter file attachment map, we specify our injected JavaScript code. And we are receiving a GET request on our server that we control. To see the response, we can modify previous JavaScript snippet in the following way. First, we issue HTTP GET request to a resource of our interest and store response data in a variable. And further, we make one more HTTP GET request to a server we control with data to exfiltrate. Here we put an updated JavaScript code in the file attachment map URL parameter. And we observe full response on the server we control. This way we can exfiltrate data from internal network resources. To exploit this, we need a GCR node with a proper resource type. Additionally, this node should have enabled server validation attribute set to true. As I've already mentioned, GCR node content user-generated at CCommerce smart lists is usually writable by anonymous user. And we can create GCR node that satisfies our requirements. As we've already discussed, this vulnerability doesn't work equally across different AEM versions. In some cases, you can achieve remote code execution. In other cases, only server-side request forgery attacks are possible. What recommendations do I have for defenders? Keep all your AEM instances up to date with installed security patches. Security Advisory from Adobe provides links for the patches to install. It's important that you should block GCR write access for anonymous user. It will protect you from plenty of attacks. And lastly, remove demo content from your AEM instances. And that's all for this talk. Thank you for participating in this session. Okay, the question is, do you see such attacks in the wild? You know, I'm not a defender. I'm work in offensive security, and in bug bounty programs, I usually test for such cases. And in previous year, I found plenty of vulnerable AEM web applications on bug bounty programs. Does the XEE exploit require the AEM instance or JVM to run as root? No. Any operating system user, if JVM is or AEM instance is running as root, then attacker can read any file from server as root operating system user. Okay, so if you don't have questions now, you can. One more question. In what way I find in this box? I have consoles that live in AEM and scan them for potential security leaks. Yes, I have local AEM installation, and I perform fuzzing of it to find such vulnerabilities. If you have further questions, you can reach me on Twitter and ask anytime. Okay, one more question. Did you try to find issues with AEM in the cloud already? No, I have not touched the cloud for now. I'm testing local AEM for security bugs, and I found that there is a huge attack surface, a lot of work to do. But it's definitely interesting place to look into. One more question. How long did you spend finding these 3 CVs? I spent a whole month in the 2019, the whole June to perform research. Then I reported it to Adobe, and it took some time for them to patch. One more question. How secure is AEM compared to similar solutions, if you tested any of them? It's a hard question because I think all software products have vulnerabilities. It depends on the what is exposed outside. In AEM, there are a lot of servlets that are exposed, a lot of bundles. Even AEM developers are not aware what they're exposing to the internet. Did you hear about any bigger hacks where people exfiltrated huge masses of sensitive information? No, I haven't heard any about any cases that are particular to AEM hacks. Okay, thank you again for watching me, and you can reach me on Twitter anytime if you have some questions.